I hope you are all well to see the video. So today we will discuss about the geophysical method or the electrical resistivity tomography, which used for the investigation of the subsurface, as a layer of the surface, as fracture of the surface and subsurface, salinity, water table beneath the ground, and up to it can measure up to 100 meters. It's depend on different type of requirement. So here we can determine also the subsurface structure, like as a drain or any cable trench. So today we will discuss the method of the ERT method. So here we will use the electrode which will be used for current and voltage measure, and another cable will be used, was multi-core cable. Here electrode or here used, which is placed which maintains the some 1 meter pace or some distance, and every coil connected here, some coil are connected to their cable, and electrode also connected at the this multi-core connected cable, sometimes some like this, and so then then and here one resistivity meter which produce the which connect with the cell, which will produce was the electric current. Here two um, two two electrode are connected to flow the current, and two electrode are connected with the voltmeter to measure the voltage. And here so now there are positive current and negative current. So here current flow through the subsurface with up to depth of the requirement, and here are two electrode distance, and will be depend on the requirement of the depth. So if you increase the two electrode the length, so it will also create the depth of the or increase of the current flow, depth of the current flow. um, and there are two potential electrode here, which create the equipotential line, and where the current drop, and voltmeter used for the measure the how many voltage will drop of here between these 2 points. So here also we can see the different type of in this is a ground level. So here resistivity depend on the and current flow, or this depend on the type of material. Then and we also see there so if a current flow through this material, so we can measure the apparent resistivity through this formula, which rho is equal R is equal to rho L by A. Rho here the apparent resistivity, R is equal to resistance, L is equal to length of the material, and A is equal to cross section of the cross section area. Here in ART test, with the one electrode placed in the and in ground surface, on ground surface, and it will generate the current, and by batteries, and its current will be dissipate through resistance of the material and create the hemisphere like resistivity. Here in air, resistance is equal resistivity is 0, so it will create only in into the subsurface, uh, um, and we we will determine the voltage. We can determine the voltage from distance and from the electrode, or like a R B, and we can different of the voltage between RA RB. So here we will follow the Ohm's law, and here R will replace the apparent hysteresis formula, and we determine the formula through integrating this, and create the main formula V is equal to I rho by 2 pi r. Here 2 pi r is the geometric vector. We will getting in the V through this test, and I by ammeter, which is current determined by ammeter, current flow, how many current flow putting in through the electrode, and we through voltmeter we can measure the voltage, and the R is the distance, and apart from electrode we can determine and through this measuring tape, and we after that we can determine the resistivity of the material. Here resistivity, different type of resistivity depends on the material, and here how many depth we have to require. So it is depend on the between in two electrode of the current flow. So we will see the how ERT test will conduct. So here two voltmeter is used. Have two electrode used for current flow, and through the by use cell and of the battery, and here ammeter used for or to measure the current, and voltmeter used for the measure the voltage through this another two electrode. Has distance is depend, so and so we know V is equal to I rho by 2 pi r. So this is the R, the distance of the one electrode of the current flow to one electrode of the potential voltage. So here C1, C2 for current electrode, and P1, P2 for potential electrode. And so C1 to C P1, and distance is equal to AM, and then this is potential electrode, and another current meter which is negative, the is equal to AM is equal to AM B. This is a B point, A point, this is a B point. So MB AM is equal, and this distance is equal to MB, and another the potential electrode from a distance, and so AN, and another is equal to NB. So we know the b is equal to the percent. We have to determine the difference between in two electrode of the electrode of the potential. So different two voltage is, so then we can determine in the resistivity, which is proportionally related. So we this distance and voltmeter reading and current meter reading, we will put this formula and we will determine the V and voltage and determine the resistivity. So here V M and Vn. So we will see how this formula will produce. So now we will see the this current from this electrode to PC1 to P1 potential electrode. How do we measure if the voltage? So we can see the VAM, that I rho by 2 pi AM. AM is equal to distance. So here we can see the uh, B BM here is equal to BM AB. So here BM MB from here CP1 to C2. So there voltage BM is equal to this is negative for negative current flow. Here minus I, and there MB for distance. So M for voltage in M by electrode of the M potential electrode, and the VAM minus VBM. So this is the VAM C P1 electrode and voltage, and we can also the uh, in electrode voltage P2 we can measure, and from a we can measure from a C1 and to P2, C1 to P2 and P2 to C2. So here also Vn voltage Van minus Vnb, and then and difference between two potential electrode, we can be voltage of the M electrode and voltage of the N electrode. So this is the main formula. Then we can determine the resistivity of the material which is beneath the ground and the subsurface. So this we will see in practically how will procedure and how will establish the setup of the test.
Scumberger is the best method, then winner, and then dipole method, which use for horizontal resolution, and pole dipole method also used for horizontal resolution, and winner method used for vertical resolutions and get a less horizontal resolution. So all method will create the negative apparent resistivity profile, and which will be used to create the subsurface investigation.
So it should be this. They should not deviate from it. and 1 meter, every 1 meter, like 4 to 5 inches deep, and every 1 meter in straight line. Okay.
Salt water added at electrode to increase the conductivity of the loose soil. The multi-core cable should be laying perpendicular to the electrode line without any overlap of the multi-core cable. What are you doing? What's yeah, Gopal? What are you doing? What is this?
This is connector. We have to make sure the connections to the electricity that we are sending to the electrodes that we have fixed.
127 electrode are used. Here 2-inch cable connect here, and 1 meter pace every electrode connect with cable, and it connect 120. So one time it electric will be produced in this cable, and resistivity will be checked. This machine name is terameter LS. Here is this equipment which are connected through with battery, and here their winch also connected with this machine, and here the multi-core cable connect with terameter LS, as which is connected with electrode through connector cable. Also the connection plug divided based on the series of the electrode here number we can see. The connector first we will create a project with
हमको क्या करना पड़ता है ना, पहले हमको एक प्रोजेक्ट क्रिएट करना पड़ता है। कोई भी प्रोजेक्ट हमने क्रिएट किया, अभी कितना प्रोजेक्ट है 5 है ना, तो नया करेंगे वो ऑब्वियसली 6 से होगा। देखो अभी प्रोजेक्ट 6 यहाँ पे जनरेट हुआ, ठीक है ना, ये प्रोजेक्ट 6 हो गया। अब क्या करना है, टास्क करना है। टास्क मतलब हम लोग उस दिन क्या देखे थे, एक स्लम्बर जरा रहा था, एक वेंडर था, एक डाइपोल पोल डाइपोल था ना, उस दिन करवाया था मैंने, डिफरेंट एरे दिखाया था, याद नहीं आ रहा है? आ रहा है ना, वेंडर में बोला था कि स्पेसिंग सेम रहेगा, किसी में स्पेसिंग ज़्यादा रहता है, तो वही करना है। तो आपको क्या करना है, जैसे मान लो कि आपको स्कैन करना है, ओके इफ यू वांट टू स्कैन है हॉरिजॉन्टल लेयर, वेरी शैलो लेयर, देन यू हैव टू यूज वेंडर अरेंजमेंट। इफ यू वांट टू स्कैन द depth wise resistivity variation, then you have to use Schlumberger array. Here see, if you are using 4 winch and each have 21 points electrodes, then we will use this spread 4 into 21, but now we are planning to take 6 into 21, so I am changing it to 6 into ऐसा नहीं हो सकता, 127, then we will choose which type method we are going to use. Is it gradient or is it dipole, is it gradient F Schlumberger? This is Schlumberger and Werner. Basically, civil engineering you need Werner, either Werner or maximum dipole or Werner. This Schlumberger. Gradient you don't need, you need this dipole or Schlumberger or Werner. We are choosing now Werner. Okay? And what is the electrode spacing? In x direction it is 1 meter. In y it is 0. Yes. And z it is also 0. Then we are okay. ठीक है, अभी हमको अभी then what we are measuring self potential means we are not going to use self potential, we are using resistivity to estimate the resistivity of the subsurface layer. So for that what we are doing, we are using the resistivity value to record the subsurface resistivity. Then next is what, stacking and minimum stacking and error limit. See, the instrument will do what? It will record at a single point 10 the subsurface layer resistivity 10 times, and it will stack it. Stack it means it will add. Store. So when it will it add 10 it take 10 time data and it will add what happened, the noise component in the data, that is out of phase component of the data will get reduced, it will get diminished, because see, if there are 4 layers, then if in the time to take each reading, it will delay for 0.7 second, and it will record the data for 0.3 second. Means to take one reading, it will take at least 1 second. Okay.
0.7 plus 0.1.
Now these are number of IP units not needed, because we are not going to measure the induced polarization here. And this is the record of full waveform. हम लोग full waveform record करेंगे यहाँ पे, ठीक है. And what is the power line frequency here? In India, the power line frequency is 50 Hz. So it have a inbuilt filter, where it will get filtered the data for 50 Hz. Okay. This is the sample rate. It is also okay. Going to the next tab. Here is the minimum current. We are sending minimum current of 1 milliampere and maximum current of 200 milliampere. Okay. We are not going to change it. Here you can change it, 500 milliampere, 1000 milliampere. But for this study, I am taking 200 milliampere. Okay. Maximum power. This is, we are not also changing this one. This is the main thing, electrode test. Here you can choose to test electrode as no or focus one. No means it will not check the electrode. If you are choosing focus one, what it will do? It will initially what it will do? It will send a 20 milliampere current to each electrode and see the if it is passed to the subsurface layer or not. Okay, because we are put some salt water. If that salt water is not enough there, or it didn't connect to the wet layer of the earth, then it will show as bad electrode, and the measurement will stop there. You have to put more water there and wet to get it correct. So we are also on it, that is electrode test. Okay, that is it. I think it's there. Or this is IP. We are not going to IP. It is borehole logging. You know borehole logging? If you are measuring the resistivity in a borehole, well, then you have to set it. Here it is not there, so also leaving it. Okay. Now it is ready to acquire the data. Okay. Let's connect first our electrode to this cable to this instrument. I'm switching it off now.
रात मिलेगा तो उधर कुछ लगाना पड़ेगा इलेक्ट्रोड्स के.
वही बोला इलेक्ट्रोड पे थोड़ा सा लोग आ रहे हैं ना उनको.
देखो इलेक्ट्रोड अभी टेस्ट कर रहा है. देखो यहाँ पे टेस्ट इलेक्ट्रोड लिख रहा है ना. इलेक्ट्रोड टेस्ट करते हैं.
उस पास होने तो मेरा टाइम नहीं लगता. जब इलेक्ट्रोड फेल हो जाए ना तब चुनते रहो, नमक पानी डालते रहो. और करने के लिए लगी रहा.
We will continue with negative apparent resistivity, because few point will come where these electrodes are not aligned in a straight line. At that point, you will get negative apparent resistivity. Because if you see the formula, there are you will show that this rho is equal to k into del v upon I. Del v value will not be negative, and current will be not be negative, and k is depend upon this spacing and the distance. If you put 4 in a single go, it is taking 4 electrode at a time. If that 4 electrode are not aligned in a straight line, then it will show some negative value. That k value will come negative, and the resistivity value will become negative. Because negative resistivity is not possible, that's why we have to discard it. Now we will measure all this negative and positive resistivity value. While processing, we will delete it.
Okay. Delete it.
We'll delete it. We'll remove the negative resistivity value, because negative resistivity is not possible.
Anything here only data collecting?
Here we only collect
not
the
showing
data.
any another.
No. Here only we will collect the apparent resistivity value. In the processing part, we'll do the other part, like removing the noise component, doing the inversion process to estimate the resistivity value from apparent resistivity value. All this stuff we'll do in the processing part. Okay.
30 out of
Here
that
37 resistivity calculated.
Total he will calculate 1149 data, from which 37 is already calculated, and we are having 4 negative values here. 4 negative values. Okay. Potential electrode.
that means it will receive.
It will use the resistivity to will use the potential calculation to calculate the apparent resistivity.
Here, after collecting the negative apparent resistivity data, the data will put in software RAC2. So here, after the putting data, we can see the subsurface profile through resolution, and so and here contrast will be so after inversioning process, and here carry out inversioning process are used. So this software, the iterative process are used to reduce the error and maximum point, and will set at with low reduced percentage, and it will give the better profile resolution. Here horizontal distance is the electrode line distance, and vertical distance is the depth of the subsurface. And here different type of error percentage. Here at last the 13% error, or it is the final to give the better resolution. And low resistivity of the pipeline, and we can see the in blue color. Different resistivity and different with different color. Here we can see the where resistivity low, where resistivity is high. So look at this, we can see also the how many electrode are working in error, and how many measure length is, and what is the electrode placing, how many iterator process it created, and what the percentage of the error. So after RMS error statistic process, so the graph is plotted here. Carpeting graph is between calculated apparent resistivity versus measure apparent resistivity, and after another graph denoting the how many point have how many percentage is error, or the how many point are selected and to this test. Here look at this, we can see the different type of resistivity and or different types of material. Here rock has a more and resistivity, and clay and graphite has a, and salt has a low resistivity, and it can more current flow. So this chart from researcher, and we can follow. So there are many difference and many variants with resistivity from rock to graphite or clay, saturated clay, sand, silty, gravel.